Hey everyone, welcome to another episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today I am joined by Mitchell Sellers, where we're going to be talking all about memory profiling today. So, hi, Mitchell.
Hi, thanks for having me.
Thanks for being here. So, tell us a little bit about yourself before we hop into the beauty that is memory profiling.
Yeah, so I am a developer technologies MVP, have been for the last 16 years. So I spend all day, every day inside of Visual Studio. Performance is one of the things that I love. And I love sharing things about performance because I find it's often overlooked and excited to be able to share a little bit about memory profiling with everybody today.
Awesome. I'm excited to hear more about it because I agree that is one, just profiling in general is one of those underutilized activities in DS, especially, which is a shame because I think there's so many cool profiling tools just within VS by default that are extremely useful. So, and we're taking a look at. So, I'm excited to dive in to the memory side of things.
Awesome.
And curious, yeah, were you at the MVP summit that as of the
Yes.
separating happened like last week? Sweet.
Yes, I
Oh,
was.
maybe we crossed paths and just didn't realize
We
it.
probably did. I think that's the
Yes.
real downside to MVP Summit is I cross paths with
So many people.
so many people, and it's like, and I know them, and I know you, and it's crazy. It's so
I
hard to
agree.
connect with like specific people at Summit. It's awesome, but
Yeah.
really, really hard to be like, oh yeah, I was there. Yeah, so was I, and you never saw each other.
Same, yeah, I felt the same way afterward. I'm like, "I think I met a bunch of people, but I feel like I missed a bunch of people." I was all over the place, I was really busy. So,
And my
yeah.
memory isn't great, so I'm bad with names, which does not help matters.
No, I know.
I
I'm
did
bad at
meet
names
Clippy
too.
though. I met Clippy. That's
Oh, really? That's so
yeah.
great. I haven't even met Clippy yet. That is a shame. I wanna meet Clippy. Although, justice for the wizard, I was always a fan of the wizard, personally. I'm not saying he's better than Clippy, but my nostalgia would be peak
That's
if
that
the wizard showed up in one of these.
that would be pretty cool too.
Yeah. But anyway, you know what else is cool? Memory profiling. So, wanna hop in?
Absolutely. Alrighty, so really, the my whole purpose here, my intent is to kind of give a really high level overview. I want to focus on the Visual Studio tooling and understanding, what's there and how things are there. So we have a couple code, I have some code samples and things like that that will be able to kind of showcase things. I just have a couple quick slides to introduce a few concepts so that we all start on the same, general knowledge page. And one of the biggest things is that it's understand what Visual Studio has available to us. A lot of times we actually have the profiling tools and things like that visible to us, but we don't necessarily think of them. So Visual Studio provides, a number of these tools and things that will allow us to be able to take a look at how our applications are working and allow us to dig in and get a full story of what's going on. The I grouped these into kind of two general areas. One being the metrics and counters, the ability to see real time charts and graphs. How much memory is your application using? How much memory in the different places are things? And we'll talk about a few of those metrics in just a little bit. We also have the ability to take snapshots. So we can freeze memory at a point in time and then do analysis. We can either do that analysis in real time or we can do a comparative analysis. And this is one of the features that it's really easy to use. There's just a button called Snapshot, but it's getting the process in place of understanding how to go about it, when you might work with it, and where we want to go. So before I dive into, the examples and the good code, bad code examples that I have to illustrate how you can see some of these things, I want to just make sure that we understand what some of these metrics are, the things that are memory specific that we want to be looking for inside of Visual Studio. So the metrics and counters that are available, that are memory specific, include a number of different items. Percentage of time in garbage collection since last garbage collection. So basically, it's letting you know how much of your processing time is being utilized by the garbage collector over a period of time. Gives you a sign of lots of memory allocations, lots of maybe inefficient memory usage. You also have your allocation rate. How quickly are you gobbling up memory within your application? And if you see a high allocation rate, that can sometimes point you to things. And these are, again, Counters or metrics. These are things that are over a period of time. So think of these as line chart type things. CPU usage, although not directly related, sometimes is a good pointer when we start to look at different elements. Exception counts also come into play because what are exceptions? Well, they're objects in memory. They're things that are going to be consuming resources. We want to make sure that we take those into consideration. We also then have various garbage collection um, information. So the number of committed bytes, the fragmentation, the size of the heap. What exactly are our overall footprints? And a lot of times with most Visual Studio configuration, fragmentation and or heap size are the only ones that are turned on by default for folks. So we want to make sure that we're kind of looking at some of those things to really get an idea of what your memory footprint looks like. You also have the ability to look at your generation 0, 1, and 2, both size and count. For those of you that are less familiar with, memory and memory management within uh, .NET, one of the leading signs, right, of a memory leak or a resource leak situation is memory items that move from Gen 0 to Gen 1 to Gen 2. So by having metrics that allow you to see growth or decline in those various generations is another way to, again, get a good idea of what's going on, as well as the working set as a whole. That working set being the overall total working set of memory allocation that you have within your application. So, in my examples here, we'll talk about all of these metrics and look at a little bit of how we see them behave when we do something naughty and when we do something following the best practices when it comes to things like string manipulation and file access. Snapshots then are a little bit of a different beast. They're a point in time look at the memory within your application. You can take multiple snapshots and you can compare them from one to another. The thing that's interesting is you can only view the detail of the items when the debugger is in break mode. So even if you're looking at snapshot, you need to break the debugging, keep your application running so that you can go in and look at the individual values. Now, what's hard is this is really, really tedious work, but sometimes it is a really easy way to be like, "Oh gosh, this makes total sense. I have 5,000 file streams sitting in memory. That doesn't look right." The key, as I look at how we work with snapshots and detailed memory analysis, is it's a snapshot of everything. So anything that .NET itself is doing, anything that Entity Framework is doing, all of that stuff is going to be visible to you in those snapshots. So it's really easy to get bogged down and lose kind of your place when you're going in to do the diagnostics. So what I think is really important as we step into this, and you'll see this as we walk through the examples, is that we really have to take our testing process and get a good scenario set up before we go in and actually start looking at snapshots. If we just snapshot blindly and try to compare, it's going to be really hard for us to make heads or tails of the information that comes out of our testing. And it's also going to be important for us to be able to repeat what we're doing so that we can actually, do some work, make a change, go back and repeat a test and get answers that actually showcase that we've made improvements. So one of the biggest things that I see folks do inappropriate in the beginning is stabilize the application and then snapshot. Um, get the application running, get everything up and going, let all of the .NET runtime stuff get stabilized, then take a snapshot. Use that as a baseline comparison. Um, unless you're truly diagnosing startup performance or startup behavior, this allows you to set that baseline and then work forward from it. And that's what we'll do today as we go through the examples, is we'll take that snapshot so that we can do the comparisons along the way. We want to make sure then that we make those processes repeatable. If you are doing an optimized performance test and you're looking at, string manipulation, make sure that you can repeat that process over and over again and get similar results, right? Everything may vary a little bit. We want to make sure that you have that repeatable process. The other
Process
thing,
the same.
exactly, right? The other thing we have to consider is, when do we snapshot? We are snapshotting memory, but memory is actively managed by .NET. So if you do a process and then snapshot, or you do a process and wait a little bit and then snapshot, you might get different results because the garbage collector may run and actually free up or clear some of that memory naturally. And if you're trying to look at, for example, why do I have a big allocation count? It's properly clearing, but it's allocating really fast. You may need to be really, really fast at grabbing that snapshot to make sure that you're able to catch it beforehand. Or you may want to wait if you're looking at the other side of things, right? If you're looking for a leak, you may want to actually let the garbage collector happen, let the natural behavior take its course. So thinking through in your process and your overall approach to make sure that you have that understood is a really good way to get yourself started. And the other piece is doing things like what I'm gonna show in the demos here, where a method is extracted out into, a console application or otherwise so that you can focus on one area is sometimes a really important diagnostic step. Sometimes with really large applications and you're trying to profile with a lot of other activity, maybe you have a whole bunch of concurrent users or a lot of unrelated functionality. If you really need to do a memory dive, a lot of times it's easier to extract out into, a test utility, a small demo application, and look at that laser focused area if you're starting to hone in on something. I find this especially important if you're working with like a third party library. We use a PDF library, for example, that had a really horrible memory leak in it. If you used appropriate .NET code, it would leak memory. If you used inappropriate code, it didn't. And it was really easy for us to be able to prove that once we pulled it outside of our application because we knew it was the culprit. Because in a memory snapshot, we saw a bunch of PDF stuff, and so it's something to just be thinking about as well that yes, you can snapshot inside of your application, but you're taking a look at memory as a whole, and you may end up gobbling up a lot more than what you're looking for. So with that, I want to dive into the demos because there's nothing better than actually showing you how some of these things work, how some of the things might go wrong, and what we're able to look at.
Yeah.
So what I
And oh, before we dive in, all the stuff that you just mentioned, that's like all in VS by default, right?
Correct. Everything here is all in VS by default. And I have my environment is should be set up right now to be just like what it would be in any regular VS. I've not docked Windows to different locations or anything like this. This is a newer install of VS. So when you're working with this in your own environments, you should see things very similar to what I am. And I'll show a couple of places to you. Like if you don't see certain dialog windows, I'll try to show you where you can find them in Visual Studio, but they should be there by default and be made available to you right away. And I will make sure, Leslie, is there I can give you a link to a GitHub repo, right? To get
Yeah,
let's play
totally.
show notes. I'll make
Yeah.
sure to get that here as well. For this sample, um, really what we did here is I wanted to really be able to show two of the most common scenarios that we see in applications that are memory related issues that sometimes go unnoticed. So one being naughty string allocations and doing string concatenation in an inappropriate manner. We all know that the code that I have here is not good. This is taking a string, it is looping through 10,000 times and basically adding a new string to it each and every time. We know this is bad, and that's not necessarily the point here. What I want to showcase here is this is a really bad example of one method that does this 10,000 times. What we need to consider is our application may not be doing this 10,000 times, but we may be doing this 10 times or 20 times per request. And we have 50 concurrent requests. That adds up to be a similar thing, right? So I'm trying to show you the same problem. Just know that, yes, I understand this is really, really bad code. I want to show you how you see these things bubble up, what we see in our metrics, what we see in the snapshots, and how we're able to kind of take a look at it. The good example is doing the exact same thing, but using string builder to just simply append that value together. So really basic C# differences between the good and the bad. We have the similar thing with the bad files. This one is actually I love this demo. I was trying to find a way to do some really horrible things, and came up with a really easy way to do it. So, bad file writing example, all we're doing here is we're looping through 10,000 times into a directory called bad file. I'm just writing a whole bunch of temp files that have a single line of text in them. So the idea here is I'm not using a using statement. I'm not calling dispose. So these file handles and the file streams are going to be left open. Now this code is full of errors. If you call the write file bad example 2 times in a row, you're most likely going to get a whole bunch of exceptions. That's why I have the try catch in here if you're playing with it on your own. But we'll also be able to see all of those leaking handles, because the good example is nothing more than using a using statement for both the file stream and the stream writer to do the same thing into a different directory. And the idea here again is to be able to just show you what could go wrong and the way things go. There's a really basic bit that just shows you all of the commands that you can enter to be able to get things going. So diving right in, we can go ahead and start our example. And so we want to take a look at what we have on our screen and what's visible here. And again, this is where everybody's environment should be somewhat similar. We have Visual Studio in the background. We have our performance demo here in the foreground. And then over here, you should see the Diagnostic Tools tab within window within Visual Studio. And depends on where you are, what you've done before. You may be on different tabs or have different things depending on the configuration. It looks like it did remember my settings from a couple minutes ago.
This theater's so underrated, I gotta say.
It is
So many people
underrated.
close it.
It gets closed. It gets
Yeah, it's
accidentally, or even it's there and just people literally never look at it. And
it's like, "Don't sleep on this window, it's so good." I've even modded a couple times and talks I've given, it's just like,
it's
it's
so
great,
crazy,
y'all.
right? So this section here,
Mhm.
the diagnostic session, these are your charts. These are your performance counters. These are the things that you're using to be able to take a look at things. There's some really hidden pieces of information in here, though, that I want to call attention to before we even hit the things that make things go silly. One of the things here is that each of these, it makes sense that these are timeline. You have your timeline at the top here, so you can kind of keep track of where it is. But notice in here your process memory chart, it has this little legend here with these extra items. These are letting you know what's happened, what you've been doing inside of your application so that you can kind of correlate as well. If you take a snapshot, there's going to actually be a pointer that gets left there so that you know what was going on at that point in time. It's really, really handy to go back and take a look at things a little bit later. Down at the bottom, we then have our individual screens. If you are like most Visual Studio developers, this is the default tab that's open when you're in this window. And so many people don't bother going to that next step. So this summary, people think of this as like, oh, exceptions, events, and teletrace things. People ignore everything that talks about here where it says memory usage, CPU usage, like
Oh,
it's right here, but
so
people don't
good.
necessarily take a look at.
Mhm.
Your
And
events.
those other tabs, like, I use the events tab all the time. I
Right,
like
exactly. Your events
Mhm.
tab is the other one that folks are probably more familiar with. This just takes care of the individual, things like, event exiting, etc.
Mm. But fun
The
fact about it also, you can view certain kinds of snapshots from there as well, like, if you, hit a breakpoint or something, you can
Right, yes, you hit a
do
breakpoint,
another
then all of a
snapshot.
sudden your whole rooted chain of the breakpoints there. The counters, this is where we control what counters show up at the top. What's really interesting here is if you have this tab open, even if you don't check the box, you can see the latest values here. You're not gonna get the histogram, you're not gonna get the timer, but you're going to get, the current value. What's really nice is, and this is where developers sometimes think, "Oh gosh, I ruined myself. I didn't get things ready to go." Well, I can go in and actually check these items and notice that the history is still there. So I just now turned on allocation rate, but I still have it for the whole timeline. So just because you didn't check the box when you had something happen, you do still get that histogram in your on running session as long as you come in and think about it as you're going here. So, don't be alarmed if you didn't, check that box when you first started or, that kind of thing. You can get those values back. For the purposes of the demo here, I'm going to make sure that we have the percent time in garbage collection, the allocation rate, um, and we'll just throw a couple of these other ones out here as well. Um, the generation 1, 2 isn't going to be there. The memory usage then is our final tab that we're going to really kind of take a look at here. This is where you do your individual snapshots. So like I mentioned as getting started here, right? The number one thing we want to do is we want to take that snapshot to get started. So I'm going
Mhm.
to go ahead and take a snapshot right now. And what you'll see in here is, okay, we are 270.26 seconds into running our application. We have 4,022 objects and we have a heap size of 407 kilobytes. This gets us our overall baseline. We can go into our snapshot and view the heap information, which we'll come back to here in a couple of minutes. But you can see here, I can see all of the things that are in memory. I can see the type of the object. I can see the count of that object. I can see its size and then its size inclusive of anything related. I also then have the ability to say, hey, I want to look at just my code. I want to hide small types. I want to look at dead objects, which we'll come back to in a second. And then I can also look at things by individual generation, which is going to become important as we get further into the demo here. And then insights. Insights is also one of the areas where you can get a little bit of a look of what Visual Studio deems, necessary. So you can see things where like, hey, we have duplicate strings, dead strings, things like that. Again, may give you a pointer to something along the way. Now, with this, then we're going to go back to our demo here, and I'm going to keep my little notes up here. And I'm going to go ahead and do my bad string demo. And what we should see here is in our bad string demo, and I'll do it one more time just so that we have two of them here.
Mhm.
And we'll see in our metrics now. Let me get that refresh going. There it goes. We'll see over here that our allocation rate has a nice big spike of 398 megabytes. That's kind of crazy, right? Lots of
Yeah.
allocation. Our garbage collection fragmentation, our committed bytes, right? All of these values go up, including our working set, right? Has taken a
Mhm.
step up. Our garbage collection heap size has also gone up in size. So we can see, as we would expect, all of that information, we saw things grow. If I take my snapshot, however, you'll see that I don't get a ton of growth, right? Not nearly as much
Right.
growth as we saw in that instantaneous bit. And that's because a lot of those things with the string thing was a point in time bit of naughty, right? And so
Mhm.
that's where we start to see that difference of like, hey, I may not be doing things appropriately, but at the same time, they're not lingering around for a really, really long time. And so then we can see here that our committed bytes are a little bit higher along the way. I'm going to force a garbage collection just so that we can um, see that everything kind of, stabilizes down, make sure that everything is where it should be. So we see here that our time spent in garbage collection, let me zoom in on that a little bit. Our time spent in garbage collection reset to 0 because I just forced a collection. Our fragmentation goes up a little bit because we have things going on. It didn't really remove anything from the committed bytes, but my heap size went back down to 0, meaning I've really collected everything out. I'm not necessarily leaking anything because I'm not growing over time.
Right.
If I do my good string manipulation now, what we'll notice is that nothing happened.
Yeah.
That's the biggest difference when we look at this from a performance perspective. And again, I can do it over and over and over again. And every single metric here is completely flatlined. I don't have any big allocations. I don't have any big differences. So that's where we can see here that we've reduced that churn. So a really good way to be able to visualize it with the metrics. If we go back to our bad string example and we run this, I'm going to run it 3 times in succession. I should do it 4. And then I'm going to snapshot right away. My goal here was to try to see if we can get anything with a little bit more detail. Didn't get a ton because again, we have a lot of, quick moving things. But if I come in and look at my insights, what we'll see here is we still don't have we don't have duplicated strings. We don't have, sparse arrays. These aren't the things that we're looking to do. Um, it did catch on that, hey, I forced a garbage collection and that's kind of naughty. So it
Mhm.
does give you some nice pointers there from a memory management perspective. But this is where we can really start to look at the dead objects is where we want to start looking at potentially, hey, we could have something, a dead object, right? Is something that should have been collected that didn't. And it looks like I did not hit my button quite quick enough because we should see strings in here as our dead object. And I did not get snapshot hit quite quick enough to get this done. But basically what we should be able to do is go in and look at the information that's there. If we go look at our strings or anything that's there, I'm going to go out of the dead objects here and just see if we can find an individual value. Let me do one more. It's the only downside to trying to do really quick demos on a high performance computer. You
Right.
have to do it really, really fast, and I didn't catch it again.
It's
Do it.
good.
We'll do the other example here, but basically you can drill into all of the detail here. One of the things that's really important to note though is if you get into something, there's a message in here that says not available. Values are only available when stopped in the debugger. This is a really interesting Visual Studio feature, we'll call it. Notice that nothing's going on. If I mouse over this, I'm getting no detail. If I
You
go
zoom in
out,
there?
yeah, I'll zoom in here. But basically, if I mouse in and there's nothing happens. I don't get a tooltip. I don't get anything else. But this is all of the instances of the signature object that exist in memory.
Mhm.
It says not available. Values are only available when stopped in the debugger. What's really crazy is if I go into the debugger and I break all, and now I mouse over an individual item, if Visual Studio is going to be correct, I can zoom in and it went away. It's a little bit highlighted there. It's a little hard to zoom in here. Let me see if I can.
But you get tooltips.
You get tooltips. You get all of the detail. You actually get to see the individual value that's in here. What is so misleading to developers is Visual Studio does not update to say or show you the value. Even if you are in, in break mode when you go into this view, it still says not available. Values are only available and stopped in the debugger. However, you can mouse over to get into it. And in here, then I can see everything. So if I'm tracking a string, if I'm tracking something else, you'll be able to kind of see that. So what we'll do is we'll kind of continue playing here a little bit. I'm going to continue my application. So I'm going to go to debug and go back to continue. And I'm going to go do that bad file example just so you can kind of see what it is here. So I'm going to do bad file, and that's going to go write 10,000 files. I'm going to go take a snapshot right now. And so the good news is I've got a little bit of a increase in items in memory. I'm just going to take a second one to make sure. But now that we go out here, we should be able to see, hopefully, a dead object. There we go. This is what I was looking for. I have 10,000 file stream objects that equal 320 kilobytes that are dead. Now I can drill into this and take a look at the detail. Now, again, oh, not available. So let's go into our debug here. We'll stop. I hit the wrong button.
I was gonna say when
I hit the wrong button. No, don't hit stop debugging. That's what really gets you. Um, but we'll go really quick back in here, get my snapshot, get back here, do bad file, take a snapshot again, go in here, and this is where we have to be careful. Dead objects. There's my file stream, debug, break all. And then I can go in here, and then this is where your extra detail and your tooltips become really, really handy. I can expand out, and I'm going to do the cheating way here to get a screenshot so we can zoom in and really look at what's here. So ignore my making it easy for people to read. But you can see here that I moused over this dead file stream. And then I can see that the file stream object is here, but I can peek into everything here. So I can actually see that I have this lingering object. Now, I took that snapshot really, really quickly, right? We could sit here and wait for a bit and take another snapshot and we'll still be able to see it. But look at how much detail I'm able to get with that memory snapshot. I can see right here, oh, this is my writing of the file 0. So this is the very first item. Now we can't get into certain things just like your other debug. This is where you then start to have to play a little bit of hide and go seek if you're running inside of a larger application. So, really great information that's available to you as time goes on. If your application continues to run, you can then start to see some of the progressions. So I can take another snapshot. You'll notice that a few objects have gone away, but I can come in here. I still have 10,000 dead file stream objects. You can also then do that. Uh, you can take a look at those individual items and compare them from snapshot 1 to snapshot 2. And this is where you then start to see a lot of those aggregation differences. So I'm comparing, for example, my snapshot difference from the start of the app to that second snapshot. And you can see here I have 10,000 file handles. I have 10,000 other things, and you can see all of the different pieces of information that are here. This gives you those tools to just kinda start to dig into it. It's all part of Visual Studio. Unfortunately, right, it's a bunch of sleuthing once you get in here, but getting that idea helps you find those right places to help diagnose and, really helps avoid needing to exit Visual Studio for anything day to day.
Yeah, I think that is really impressive, and again, all this is through the diagnostics tools window. And, you mentioned that, like, you do have to do some sleuthing here, but there's also the full-on performance profiler that people could take advantage of if they really want those more, like, detailed analysis, right?
Exactly, right? This is just looking at memory, right? You have the performance profiler, you have other things, that go even further into it, right? This is like I know I'm looking for something in memory. I can get a really quick look really easily without having to do a bunch of extra work.
Yeah, so people got options. They want the quick way while they're just running their code, they can go that route, and if they want the one that's like, "Here are the major hotspots in performance profiler land," then people can do that too.
Exactly, and that's where, like, the analysis of the performance profiler, you get all kinds of extra stuff, and memory usage is one of those items that you get available within that. So,
Mhm.
absolutely.
Pretty sweet. I love it. So don't the lesson today is do not close the diagnostics tools window.
Do not do it.
Love it.
It is so hard because it's only there, right? That diagnostics window goes away when you get out of debug mode, and that's one of the biggest things for developers. They're like, "I don't see it, I don't see it." You
Yeah.
gotta be in debug mode to be able to get the diagnostics window.
Yeah.
And so that's the biggest thing, and really avoid closing debugging. Like you saw, I even did it here. It happens, and you do have to kinda start over a little bit. That is where some of the other tools help a little bit more too, performance profiler, etcetera.
Sweet. Well, thank you so much for chatting all about that, and we're gonna post the link to that demo, below, so check out the description, folks, if you wanna experiment with that same code. And, yeah, anything else, Mitchell, before we
No, I hope
sign
it's
off?
helpful. It's a fun tool. It just takes some time to really get to be able to use it well,
Mhm.
and, but the more you look at it, the more you'll be able to understand it, and just knowing that it's there. That's my biggest encouragement to developers. Even if you don't wanna go into all of the intricacies of what, generation 0 and 1 and 2 is and how all of that works, just so you can still get a peek of what's in your application in memory. And that will really, it's amazing how quickly that can point you to problem areas of your application.
Absolutely. So, always cool to see someone enthusiastic about profiling, talking about profiling because it does not get enough love, I think, in the Visual Studio space, especially
Nope,
given
not at
how
all.
much of that is there by default at your disposal. You don't have to install anything extra. It's just there, y'all. So check it out if you don't already. Don't close out Diagnostics Tools window. And thank you once again, Mitchell, for being on the show and talking about some memory profiling goodness. So until next time, viewers, go try it out and happy coding, y'all.